Hello dear students. In our previous class, we had a discussion about how to find the determinants of a 2 by 2 square matrix, 3 by 3 square matrix, and finding minor of an element, cofactors of an element, and inverse of a matrix. Those are the concepts we have learned in our previous classes. Today, we are going to learn a new and interesting concept is applications of determinants and matrices. So what is the importance of applications of determinants and matrices? For solving the system of linear equations in 2 or 3 variables, system of linear equations. By listening the word system of linear equations, somewhere we have this concept where in class 10th. In class 10th, we have learned how to solve system of linear equations for 2 variables. There we have learned solving the linear equations for 2 variables in 3 methods. One is substitution method, elimination method, and cross multiplication method. Using these 3 methods, we know how to solve a pair of linear equations in 2 variables. Now, the same kind of equations, linear equations, we are able to solve by using determinants and matrices. How to solve by using determinant and by using matrices? System of linear equations. As we know that linear equations are 3 types. Type 1, intersecting lines. Type 2, parallel lines. Type 3, coincident lines. When the lines are intersect, we have only one solution. When the lines are parallel, we don't have a solution. When the lines are coincide, we have infinite number of solutions. So here the solutions are depending on the lines. Now here also, when we are talking about system of linear equations, these system of linear equations may have a solution or may not have a solution. Then how can we say they are having a solution, they are not having a solution? Now, what are the system of linear equations we have? For example, a1x plus b1y is equal to c1. a2x plus b2y is equal to c2. So, these are nothing but what? System of linear equations in 2 variables. What are the variables we have here? X and y are the 2 variables. Similarly, a1x plus b1y plus c1z is equal to d1. a2x plus b2y plus c2z is equal to d2. a3x plus b3y plus c3z is equal to d3. These are nothing but called system of linear equations in 3 variables. What are the variables here we have? X, Y, Z. So X, Y, Z are nothing but 3 variables. So these are the system of linear equations in 2 variables and these are the system of linear equations in 3 variables. Now today we are going to learn how to solve 2 variables equations and 3 variables equations. So, to know the solution of these equations, we have to know whether they are consistent or inconsistent. So, what is the meaning of consistent and inconsistent? Here we have the consistent system. What is the meaning of consistent system? A system of equations is said to be consistent if its solution exists. So, when we have these system of linear equations, for example, now we have these are the system of linear equations. When we can say these linear equations are consistent, means if these equations are having a solution. How many solutions? Either one solution or more number of solutions. In that case, we can say the system of linear equations are nothing but called consistent. Now coming to the inconsistent. What is the meaning of inconsistent? There is no solution for the system of linear equation. So, its solution does not exist. Where we have a solution, they are nothing but called consistent system of linear equation. Where we don't have a solution, they are nothing but called inconsistent system of linear equations. So, by using applications of determinants and matrices, we are going to learn about how to solve the system of linear equation. What is the meaning of solving the equations? As we know that solving the equations mean finding the unknown values. Unknown values means variable values. Here I have variable x, y, z. Now I need to find what is the value of x, what is the value of y, and what is the value of z. So finding the value of x, y, z is nothing but called solving the system of linear equations. So today we are going to learn that process. Now let us see how to solve the system of linear equations. Now here we have solution of system of linear equations using inverse of a matrix. So we are going to solve the system of linear equation using inverse of a matrix. So, how to solve the system of linear equation using inverse of a matrix, that we are going to learn here. Now, this is just we are going for the generalized method of solving the linear equations. For example, when we have these are the system of equations. How many equations we have? 3 equations. When we have 3 equations means we have 3 variables. When we are talking about 2 variables x and y, you will have only 2 equations. When we are talking about 3 variables, you will have 3 equations. When we are talking about 4 variables, definitely we have 4 equations. So the number of equations are depending on the number of variables. When we have x, y, z or 3 variables, certainly you will have 3 equations. So the first equation we have a1x plus b1y plus c1z is equal to b1, a2x plus b2y plus c2z is equal to b2, a3x plus b3y plus c3z is equal to d3. Now, what is our concept? Using inverse. Inverse means again we need to go for matrices and determinant. Do you find any matrix here? No. So first the given system of linear equations we should convert in the form of matrices form. How to convert it? Let me explain. Now, what are the linear equations you have? Let us try to convert them into matrices form. How to convert it? Now, the given equations I am able to convert in the form of matrices equation by considering only the coefficients of a variables. In the first equation, when I talk about the first equation, what are the coefficients we have? a1, b1, c1. So, a1, b1, c1. When we talk about the equation 2, again what are the coefficients we have? a2, b2, c. a2, b2, c. When we talk about equation number 3, a3, b3, c. So this is one square matrix we have. By connecting all the coefficients of a variable, we are getting a square matrix. Now what are the variables we have? X, y, z. Now all variables we consider as a column matrix. Now the constants, all constants we consider as again a column matrix. So the system of linear equations, these are the system of linear equations, all these converted in the form of a matrices form. Here I have one matrix and this is one matrix and this is one matrix. Now when we observe this matrix, how we form this matrix? By collecting the coefficient. That's why this matrix is named as coefficient matrix. Now this is nothing but called variable matrix. Now this is nothing but called constant matrix. So here we are getting three matrices based on coefficient, based on variable and based on the constants. So step 1 is completed. What is the step 1? Converting equations into the form of matrices. Now what is our question? Using inverse of a matrix. Now where is the inverse of a matrix? Let us see here. Now here I have three matrices. Now I am going to name them. So the first matrix I am considering as capital A, the second matrix I am considering as capital X, the third matrix I am considering as capital B. Now what I have, that is I have Ax is equal to B. Now I have a equation. Now we need to simplify this equation. How to simplify it? Multiply A inverse on both sides. When we multiply A inverse on both sides, that is A inverse into Ax is equal to A inverse into B. By applying the associative law, A inverse into A into X is equal to A inverse into B. By applying multiplicative inverse, A inverse into A becomes I into X is equal to A inverse into B. By applying the multiplicative identity property, I into X is X is equal to A inverse into B. So now we have another equation is that capital X is equal to A inverse into B. Here X is nothing but variable matrix. How you will get the variable matrix? By multiplying A inverse and B matrix. So first we need to find A inverse. First we need to find A inverse. How to find A inverse? Yes, we know finding the A inverse. How to find A inverse means we have a formula that 1 by det A into adjoint of A, where det A is not equal to 0. So again we have, it is a formula for finding the A inverse. So A inverse is equal to 1 by det A into adjoint of A, where det A is not equal to 0. As we know that when det A is equal to 0, A inverse does not exist. When det A is not equal to 0, then only we have a solution. So here A inverse, if you want to find, first we need to find det A. When det A is not equal to 0, then we proceed the finding A inverse. And again here we have two cases. As we discussed, the consistent and inconsistent. How can we say consistent and inconsistent? When det A is equal to 0, A inverse does not exist. When A inverse does not exist, there is no question of finding the x value. Means there is no solution. Means they are called inconsistent. When det A is equal to 0, when det A is not equal to 0, we have A inverse. When A inverse exists, we can find the x value. Then we have a solution that is nothing but called consistent. Here we have two cases. Case 1, if that A is not equal to 0. If that A is not equal to 0 means have a solution. Case 2, if that A equal to 0, not having a solution, not having a solution. So these are the two cases we have. Case 1, if determinant of A not equal to 0, we have a solution. How many solutions? Only one solution. In this concept we are going to discuss about only with one solution. We don't have a problems to have more number of solutions. So if that A is not equal to 0, we can say that the system of linear equation having a solution. Case 2, if that A is equal to 0 means system of linear equations are not having a solution. This is the generalized concept of solving a system of linear equations. Now we see one or two problems how to solve the problems by using matrices and determinants. Here we have example number 27 from page number 134. Solve the system of equations. When we observe here, we have two equations. When we have two equations means we have two variables. Now we need to find the value of x and the value of y. How to solve this system of linear equations? As we know that by using inverse of a matrix. So using inverse of a matrix, how to solve this system of linear equation we need to know here. As we know that the given system of linear equation we need to convert into matrices form. How to convert them? So first we need to consider the coefficients. What are the coefficients we have? In first equation I am talking about the coefficient. What are the coefficients we have? 2, 5. So 2, 5. And second equation, what are the coefficients we have? 3 and 2. So 3 and 2. Next, variables. What are the variables we have? X, y. Next, constant. What are the constants we have? 1, 7. So the given system of linear equations we are able to convert in the form of matrices form. We have a coefficient matrix, we have a variable matrix, and we have a constant matrix. Now let us see, as I told you, this coefficient matrix we need to consider as A, and the variable matrix we consider as X, and the constant matrix we consider as B. So where matrix A is nothing but 2, 5, 3, 2. The variable X we consider as X, Y, and the matrix B we have 1 and 7. A 2, 5, 3, 2, X, X, Y, B 1, 7. These are the matrices we have. Now, the matrix B. First, we need to know that whether the given matrix is a singular or non-singular. First, we find that A. That A is equal to that 2, 5, 3, 2. As we know that the cross multiplication, 2 2s are 4 and 3 5s are 15, minus 11 is not equal to 0. That is A is a non-singular matrix and A inverse exists. A inverse exists. When A inverse exists, we need to find A inverse. To find A inverse, first I require adjoint of A. Adjoint of A. As I told you, how to find the adjoint of A. When this is the matrix A, adjoint of A matrix, what I told you, the non-singular, these are the diagonal element, principal diagonal element. Principal diagonal element has to interchange. So, 2 and 2. Non-principal diagonal elements, for these two elements, we should change the signs. Here 5 is positive, we have to take it as negative. 3 is positive, 3 also we should take as negative. So we have -5, -3. This is about adjoint of a matrix. Now we need to find A inverse. What is A inverse? A inverse is equal to 1 by det A into adjoint of A. That is equal to 1 by det A into adjoint of A. Det A, how much we have? -11. So 1 by -11 adjoint of A, 2 -5 -3 2. Now that can be written as -1 by 11 into 2 -5 -3 2. This is about A inverse. Now what is our aim? Our aim is to know the variable matrix. Means we need to find the value of x. How to find the value of x? Now we have a formula for variable x. What is that? We have what we have? Ax is equal to b. From this we have x is equal to A inverse into b. That implies x is equal to A inverse. What is A inverse? We have -1 by 11 and 2 -5 -3 2 into b. B means constant matrix. 1 7. Now we should multiply. When we multiply -11 into first row, will multiply with first column. 2 ones are 2, -5 into 7 -35. Now second row into column 1, -3 into 1 -3, 2 sevens are 14. That gives us -1 by 11 into 2 -35 -33, 14 -3 11. Next, now x is equal to this -1 by 11 we multiply inside, means -33 by -11, 11 by -11. This can be multiplied. When we multiply these, minus cancel, 11 ones are 11 threes are 11 ones are 11 ones are. Finally, we have x is equal to minus plus 3 and minus 1. What is x here? X is nothing but variable matrix. So the variable matrix is xy, and here we have a matrix 3 minus 1. When these two matrices are equal, the corresponding elements are also equal. Means the value of x is equal to 3 and the value of y is equal to minus 1. So that is the way we solve system of linear equation by using matrices and determinants. So first step, the given system of linear equations converting into matrices form. Then we find determinant of coefficient matrix, that is A. When the determinant is not equal to 0, then we can call it as a non-singular matrix. Then we are able to find the A inverse. Once if we know the A inverse, we can find the X. So this is the procedure to find the system of linear equations and to solve the system of linear equations for two variables. Today we restrict for two variables. In our next class, we see how to solve the system of linear equations in three variables. Let us see one exercise problem again to solve the system of linear equations into two variables. Now, the system of linear equations are given for us. 5x plus 2y is equal to 4. 7x plus 3y is equal to 5. We have two equations. Now let us see how to solve it. Given equations are 5x plus 2y is equal to 4, 7x plus 3y is equal to 5. Converting them into matrices form. Now, convert into matrix equation form. That is, taking all coefficients 5, 2, 7, 3, taking all variables x, y, taking all constants 4, 5. Now, where A is equal to the coefficient matrix 5, 2, 7, 3. The variable matrix is x, y, and the constant matrix is 4, 5. Now we find det A, det 5, 2, 7, 3. Here 5 3s are 15 minus 7 2s are 14, 1, which is not equal to 0. When determinant is not equal to 0, that is A is a non-singular matrix and A inverse exists. Now, A inverse is equal to 1 by det A into adjoint of A, that is equal to 1 by 1. Adjoint of A, as we know that adjoint of A means what? When this is the matrix A, the principal diagonal elements has to interchange. Principal diagonal element has to interchange means we get 3, 5. Here actually we have 5, 3. When we interchange, we have 3 and 5. And non-principal diagonal elements, we have to change their signs. So we have -2, -7. So finally we have 3, -2, -7 and 5. This is about A inverse. We know that Ax is equal to B. That implies x is equal to A inverse into B. So here we have matrix equation form. This is A, this is X, this is B. So A into X is equal to B. That we have. So from these, the value X means the matrix X we get A inverse into B. Now let us simplify. That is X is equal to A inverse. What is A inverse? 3 minus 2 minus 7 5. B. What is the B matrix? 4 5. 4 5. So that is equal to here row 1 into column 1. 3 into 4 12 minus 2 into 5 minus 10. Row 2 into column 1 minus 7 into 4 minus 20, 5 5 7 25. That is equal to 12 minus 10 to minus 28 plus 25 minus 3. That implies small x small y is equal to 2 minus 3. When these two matrices are equal, their corresponding elements are also equal. Here capital X, this is nothing but what? Here we have capital X, here we have capital X. Capital X means what? Which is a variable matrix. So we have written XY, it is a column matrix and it is also a column matrix. These two matrices are equal. When two matrices are equal, their corresponding elements are equal. So here the first element is X, here the first element is 2. So X is equal to 2. Here the first element is Y and here the first element is minus 3. Y is equal to minus 3. So we have X is equal to 2 and Y is equal to minus 3. So this is the procedure to solve system of linear equations into two variables. In our next class, we discuss how to solve system of linear equations in three variables. Thank you.